Hello, my name is Christopher Bravery. I'm a consulting scientist, consulting regulatory scientist at Advanced Biologicals. Like many of you, lockdown gave me a little bit more time to do some reading and so on than I would normally have, perhaps. And I was taken by a rather bizarre comment made in a paper from the advanced therapy community, stating that potency assays were a new concept developed in the 1990s in order to deal with biotechnology products. And that made me think that perhaps many people that have fallen into biological products development and so on haven't necessarily had the training or the history. And I thought maybe it would be interesting to give a short talk about the history of biological standardization. So the regulation of medicines actually has a very long history. It's just that we didn't have a sort of a fully formed system like we have today, but we did have many of the elements in different ways for a very long time, maybe back to the 1500s in the UK. But always, even today, we have concerns about adulterated products and materials and so on. I mean, this terminology is still used by the FDA in the CFRs, for example. So here's an interestingly, succinctly entitled book by John Chandler in 1748 about frauds detected, etc., etc. I'm not going to read it out. It was basically a rant about adulterated materials and how it was difficult for apothecaries to get hold of good quality materials, many of which were imported and expensive, and therefore adulterating them in order to make them pad them out, so to speak, so that you could make more money was obviously quite tempting. The first Pharmacopoeia in the modern sense is accredited to Florence, in the city of Florence, that is, in 1498. However, you can go all the way back to the Egyptians and possibly before that to find texts that are really not too dissimilar. And the Egyptians actually had quite a sophisticated regulation of medicines. Somewhat better than it was for maybe 1,000 or 2,000 years after that. But from 1498 onwards, as you can see, there was a lot of city-state pharmacopoeias published. And if we look at the Pharmacopoeia Londinius, which was first published in 1618, in Latin. So this is a page from the 1653 version, which was now in English. And you'll see that actually the majority of the medicines described in the Pharmacopoeia were actually biological medicines, including roots and barks, but all the way down to parts of living creatures and excrements, which must have been a little bit unpleasant. And rather few of the materials in there were what you might describe as chemical. I mean, the rise of chemical pharmaceuticals was really something that occurred from about 1900. And from maybe the 1950s, 60s, well, certainly the 70s onwards, we've got the rise of sort of modern biotechnological products. But in between all that, we still had a lot of other biological products, as I'll move on to. The conclusion of Chandler's rant in 1948 was the only check which has hitherto been laid upon these unwarrantable practices has been the powers granted by the College of Physicians and the Company of Apothecaries to visiting shops and inspecting medicines. So this refers to the Pharmacy Wares and Drugs and Stuffs Act of 1540, which was basically a sort of predecessor of GMP. The physicians and apothecaries were allowed to go and inspect apothecary shops, and remove or destroy any materials that weren't considered to be of adequate quality. although the concept of quality, I think, is rather limited at this time. By the early 1700s, we're starting to get national pharmacopoeias, and presumably these are then legally enforced, as certainly the UK one was, so I'm assuming the others were too. We have just passed the 200th anniversary of the United States Pharmacopoeia, which was called the Pharmacopoeia of the United States, and Pharmacopoeia was spelt in an English way. And it was founded in January of 1820, and the first volume was published in December 1820, and I've looked at it and it was a bit thin. In Britain, we were a bit behind, but we were consolidating the London, Dublin, and Edinburgh versions, national city versions, into one single pharmacopoeia. In 1799, we had the launch of what you might call the first pharmaceutical sciences journal, the Medical and Physical Journal. Although I wouldn't swear by that since I haven't gone around to look for sure. But I was very intrigued by a letter in the first volume of this journal of 1799 that said we would submit to the legislature and the proprietary of erecting a public board composed of the most eminent physicians for the examination, analyzation, and approbation of every medicine before an advertisement should be submitted into any newspaper or other periodical publication, and before it should be vended in any manner whatsoever. And this was really a response to ongoing public debate about the poor quality of medicines at this time, and the number of medicines that were being advertised as being cures for all sorts of things were in fact snake oil. It took until 1968 for us to have a fully composed Medicines Act that actually enacted this idea, along with all the other elements that were already in place. But mostly I want to talk about biological standardization, but obviously that becomes part of the regulation. So we've got Edward Jenner in 1796 founding modern vaccinology with a method, of course, that was used in the Middle East for hundreds of years before. So it wasn't entirely new. Then Louis Pasteur, this was now really the Industrial Revolution. And it's easy to forget the Industrial Revolution wasn't all about steam trains. It was actually a revolution of scientific knowledge and so on as well. So we have Pasteur understanding the concept of attenuation, which was very important for vaccines as well. But all of that was a little bit risky before Robert Koch came along with his Untersuchungen über die Etiologie der Wundinfektionskrankheiten, which was an understanding of the etiology of wound infections and bacteriology in general. In 1888, Emil Roux and Alexandra Yersin demonstrated that the lethal effect of diphtheria, and you can imagine diphtheria was a serious problem still in the 1880s, was due to a toxin released by the bacterium. So it wasn't the bacterium itself, it was a toxin. Following this, Emil von Behring discovered that if she treated bacteria with iodine trichloride before injecting that into guinea pigs, the animals survived. Furthermore, if she transferred that blood to another guinea pig and then tried to infect that guinea pig with diphtheria, that guinea pig survived as well. This idea was very exciting at that time because a lot of people died of diphtheria, and it was very quickly scaled up by von Behring herself and others. The issue was that the effect tended to be a bit variable. And here's when we come to the genesis of potency assays and reference standards. Paul Erlich, now many of you will know the name Paul Erlich, if for no other reason that one of the German medicines agencies is named after Paul Erlich. He was working with von Behring at the time. Now, Paul Ehrlich is a very interesting guy. If you don't know much about him, I really recommend going to read some history on him, because he was extremely clever and developed a lot of things, actually. He suggested that the blood from each batch, if you like, could be compared to a batch of blood that was known to be effective as a way of determining its strength, or indeed, as we'd now say, potency. He even prepared a dried form of these diphtheria and antiserum, which he kept in a vacuum at 0 degrees C to make it a preserved, stable reference standard. And he assigned units of diphtheria activity to this. So this was a reference standard. And indeed, it may well be argued it was one of the first, if not the first, international reference standard, because he distributed this globally to others that were preparing diphtheria antitoxins so that they could compare to it. And indeed, if you look into some of the pharmacopoeias around this time, you start to see the units of these antisera being introduced. And then there was an awful lot of other work that went on in the years subsequently. If you're interested in insulin, there's a lot about the units of insulin and what a revolution that was. But as you can appreciate, if for doctors around the world trying to administer products to treat things like diphtheria or diabetes with insulin, if we all have a common unit of activity, then it doesn't matter if the material is made by a different process. We can confidently know what dose to administer to patients. And there's an awful lot of interesting literature I read around this that I don't have time to go into. Of course, a reference material is of little use without an analytical means. And at the beginning, of course, they were using animals, the guinea pigs, the von Behring that I've just mentioned. And Paul Erlich refers to that here. But Paul Erlich was probably better described as a chemist. I don't know, he was everything really. Anyway, but he was certainly very knowledgeable in chemistry. And so he was disappointed by the lack of accuracy of this bioassay in an animal. And he realized that there was a need to standardize it. So he worked on the first in vitro potency assays. So, he says initially it's important to eliminate as far as possible these variable factors. And then he says that he was happy to find that if he took just the red blood corpuscles from the guinea pigs, then he could separate those out into multiple test tubes with the same homogeneous red blood cell material. And then he could consistently measure the actions of various toxins, including ricin, eel serum, snake poisons, tetanus, and so on. And that these became a very good method of potency assays, as we would call them today. They gave him the sort of consistency and analytical accuracy that came closer to chemistry. It's never going to be quite as good as chemistry. One of the other sort of main big names in the history of biological standardization was Gadom. And in his inaugural address published in 1942, he was becoming professor of the Materia Medica and Pharmacology at Edinburgh. In this work, pharmacological methods, now they're the things that we would now call bioassays, are used to detect and measure substances such as vitamins, hormones, and bacteriological and immunological products, which cannot in the first instance be detected or measured by any other way, since chemical methods either do not exist or are much less sensitive. So this so these assays have been used to control the chemical work sorry, I'm losing the plot slightly. So when the active substance has been isolated and when its chemical structure has been established, it is sometimes possible to replace these biological assays by a chemical method. Now that still remains true today, but only if the substance you're measuring is chemical. If it's biological, we still don't accept that we really can replace that with chemical methods. Although, maybe there's a few areas where we're beginning to think that, like insulin, that's simple. But as yet, we haven't quite reached that point in replacing these sort of assays for true biological materials. Another big name in biological standardization was Miles. And he published this paper in 1949, The Biological Unit of Activity. And he says that the unit is superfluous only when the biological assay ceases to be a necessary part of the specification of materials prepared routinely, and when chemical and physical tests alone are sufficient to predict biological activity. Now, that's true, as I say, for chemical substances, but it remains not true for biological substances. Now, all these efforts went on, and globally, it was really recognized the importance of this biological standardization to consistent effectiveness of these now vital biological medicines like anti-serers and so on. And even and the predecessor, I suppose, to the United Nations, the League of Nations, met in London in 1921 to start a biological standardization program, basically. And their objective was to provide reagents with assigned units of activity so that everyone could use them. And in particular, this would be things like the diphtheria, tetanus, etc., etc. And this activity continues today and has been taken over by the WHO, who now still continue to produce biological reference standards for important biological medicines. Derek Bangham was another name in biological standardization, and he addressed something that I've also seen in ATMP literature, and probably it's elsewhere, this misunderstanding of what a reference standard is. So I've seen it described as a gold standard, as if you would have to comply with every aspect of that reference standard. And as he explains as he explains here, biological standardization refers to the methods and materials used to characterize and quantify a biological substance. It does not mean the restriction of a substance to a single type of material or preparation. So we shouldn't be scared of biological standards, and we shouldn't misunderstand what they're for. It's actually a Pharmacopoeia monograph that provides you a full specification. A reference standard is there purely to provide the units of biological activity, or actually we use the term reference standards to provide the units for other things too. So here I have a simple ruler, which is going to look a bit funny when it pokes out, but the ruler is a reference material or a reference standard for length. This one, not particularly accurate, but it's stable enough within the conditions that I'm likely to use it. If I got it too hot, it would melt. If I got it too cold, I might shatter it, I suppose, but its length might vary a little bit. So this is an important aspect of reference standards, that there are certain conditions under which they are suitable, but it is a reference standard. And in fact, it would there was once a metal reference standard that was the standard unit of length, the meter. So a measured amount of biological standard is assigned to define a quantity of that activity in terms of a number of units of biological activity. In this sense, the international unit for those international biological reference standards is the same, if you like, as my ruler that I just showed you. It is a reference standard. It allows you to measure the potency of something. And this is because biological activity can't be measured in SI units. It can't be defined as length or mass or electrical conductivity or whatever the other SI units are. It is defined by a physical artifact in the same way actually as the kilogram was until only about 2 or 3 years ago. So in conclusion, and that whiz through biological standardization, I think this quote from Bangham rather describes where cell-based medicines are today. When the purity of the substance is not known, or if its structure or its possible heterogeneity is ill understood, And if the method of assay is not known to be selective or specific for the substance, then the whole process of quantification becomes an imprecise estimation and of uncertain validity. Now, that really could be written about cell-based medicines, because at the moment, a living cell doesn't make a very good reference material because it's not stable enough. And autologous bring even additional problems. And in fact, the bioassays we're using, it's hard to know for sure whether they're measuring something relevant. So the message to the cell-based ATMP developers is we need to work on this problem, because at the moment our measures of potency are not truly measures of potency. They're using bioassays without a reference material. And it's really a big problem that we need to solve in order to standardize ATMP potency. Thank you for listening.